Hello everyone, thank you very much for joining the tutorial session. In this class, I plan to provide 3 tutorial sessions for the whole term to introduce the preliminary knowledge related to pavement design. In the tutorial session today, I will introduce the pavement distress. In this class, we will learn how to minimize or delay the occurrence of distress, which would be the purpose of the pavement design, and how to replace or fix them, which would be the maintenance task. So it's very important for us to understand what kind of pavement distress it is and their potential causes. In pavement design, we usually consider 2 types of the failures, structural failure and functional failure. For structural failure, there will be some breaks or friction about the pavement structures, which will make the pavement unable to provide the support for traffic load. While for the functional failure, we will not observe any structural problems for the pavement, but the pavement was designed and was unable to provide a smooth ride for the vehicles on the road, and this is actually called the functional failure. The surface stress is an indication of poor or unfavorable pavement performance or signs of impending failure. So any unsatisfactory performance of the pavement shows the structural failure. In this tutorial, we will discuss about the pavement distress categories and their cause with respect to the flexible and rigid pavement. Let's first go through flexible pavement distress. The distress in flexible pavement can be categorized into 5 types: cracking, rutting, surface deformation and defects, potholes, and miscellaneous distresses. We will go through them one by one in this tutorial session. Here will be some more detailed distress mode for the flexible pavement. For cracking, we will consider the longitudinal, transverse cracking, pattern cracks. Under the longitudinal cracking, we will consider the fatigue cracking, seasonal cracks, joint construction cracking, edge cracking, and so on. We also will discuss about the rutting and its potential causes. For all the other types of the distress in flexible pavement, we will consider them as others, including the potholes, bleeding, raveling, striping, and so on. First, let's go to check fatigue cracking or alligator cracking. This one is pretty common on the local roads and freeways. Generally, the type of the cracking is caused by the fatigue failures of asphalt under the repeated traffic load, and it usually occurs along the wheel paths and parallel to the lane markers. And it may also present at anywhere in the lane because the cars might be wandered at any locations on the lane to make lane changes, or there might be some impaired drivers on the road. These 2 figures show several examples about the alligator cracking caused by the repeated load. And if we pay attention about some local roads, you will find some similar patterns. Usually the fatigue cracking initiates at the bottom of the asphalt concrete, and this kind of cracks will propagate upward to the road surface. It only occurs at the areas near or within the wheel path. So we also call them as the wheel track cracking. There will be some minor, moderate, and high wheel track cracking. And when it's severe, we need to find a way to fix the surface to provide some smoother ride on the road. The second one is the transverse cracking, which is perpendicular to the pavement center line, and the cracks will occur at partial lane, or it can extend to all the travel lanes on the road. The next type of cracking is the block cracking, which is also called thermal cracking. It will divide the pavement into larger rectangular pieces or blocks. Usually it's caused by the effect from the temperature changes, especially the thermal shrinkage of the asphalt binder, or the aging of the binder layer will also increase the formation of this block cracking. This type of cracking is not caused by the fatigue or the repeated traffic load. Here are some examples of block cracking, and you will observe a lot of rectangular pieces which were formed by these cracks. The next one is joint reflection cracking. This one usually occurs on pavements where the asphalt surface is overlaid on a joined concrete slab. This crack usually occurs over transverse and longitudinal joints where the pavement was widened. The type of the cracking is caused by the movements of the slab behind the asphalt surface, and this kind of movement usually is caused by the temperature and moisture changes. And the knowing slab dimension beneath the asphalt concrete surface will actually help us to define the reflection cracking at the joint. The two figures on the left actually demonstrate the cross-section view and top-down view of a pavement with joint reflection cracking. And you can see that they are very different from transverse crack. For the joint reflection cracks, they occur at the joints of two PCC slabs at the bottom, while the transverse cracking occurs when the PCC slab at the bottom has some cracks and is transferred to the surface. In reality, you will see some joint reflection cracking. They have very regular patterns, which will be very similar to the layout of the PCC slabs on the road. Here we have more examples about the joint reflection cracking, including top-down view and cross-section view, and they all occur at the joints of the PCC slabs. Another type of cracking is longitudinal cracking. This type of cracking is usually parallel to the pavement center line. The longitudinal cracking can occur within the lane. It could be aligned with the wheel path, or it could be aligned in the middle of the lane. The location is very significant. The longitudinal cracking can be load related. In that case, it will be aligned with the wheel path. Well, if it's caused by the poorly constructed pavement, then it will be no-wheel path longitudinal cracking. Also, for asphalt overlay, the reflective effect can cause some longitudinal cracking. Here are two examples about longitudinal cracking. Both of them will cause the cracks in the middle of the lane. Another type of cracking is top-down cracking, which is also one type of longitudinal cracking. In this type of cracking, the cracks will occur from the surface of the pavement and propagate downwards. This one is highly related to the properties of the asphalt concrete. There are many potential reasons about top-down cracking. The first one is non-uniform vertical loading. This can result in high surface tensile and shear stresses. On the road, the vehicle loading can be non-uniform by a lot of reasons, including the load distribution, axle and tire configuration, floating axles, pavement across four wheel path locations, and so on. The second one is poor or inconsistent hard mix asphalt quality, production, placement, and compaction. Also, the interlayer slippage or delamination will have some contribution to top-down cracking. Thermal stresses, stiffness gradients within the surface course and between the asphalt concrete courses, premature asphalt concrete edge hardening, they will all increase the potential of top-down cracking. Another major distress of flexible pavement is rutting. This type of distress is represented as unrecoverable longitudinal depression along the wheel path. The rutting will cause a lot of problems for the pavement. For example, after the rainfall, the waters will fill in the ruts and cause the vehicle hydroplaning, and also they will lose the traction when there's an ice in the winter, and they can tend to pull a vehicle toward the rut path when they are trying to make lane changes. This will increase the risk of the collisions on the road. Rutting is the depression forms in the wheel path. It could be the permanent deformation in any pavement layers or in subgrade. There will be two major causes of rutting. The first one is the compression or the lateral movements of the materials due to the traffic load. And the second one is the plastic movement of the asphalt in hot vessel or inadequate compaction during construction. The rutting usually related to the weak asphalt mixture, for example, the high asphalt binder content, low air void, low-grade asphalt binder, and so on. And also, if the pavement structure is not designed properly, it will easily form rutting on the road. There are two types of rutting on roads. The first one is a consolidating rutting, which is usually caused by the excessive consolidation of the pavement along the wheel path. And this one is highly related to the repeated load on the road. The figure here demonstrates the effect of the consolidating rutting. And this one is also called structural rutting. In most of the case, the consolidating rutting is caused by the permanent deformation of the base or subgrade layers. It could also be caused by the reduction of the air voids in the asphalt concrete layer. The second type of rutting is instability rutting, which is also called the non-structural rutting. The figure here demonstrates the effect of instability rutting, and it usually occurs within the top 15 millimeters of the asphalt concrete layer. The failure of this type of rutting is attributed strictly to the asphalt mix property. These two figures demonstrate the instability rutting in reality, and you can check the cross-section of the pavement, and you will observe that there are only deformations occurs at the top of the asphalt layer. In reality, the most efficient method to prevent instability rutting is applying the right aggregates so that they can support repeated load on the road. Bleeding is another commonly observed distress of flexible pavement. It's characterized by excess asphalt binder on the surface of the pavement. This one has a very serious problem. It will create a shining glass-like reflective surface. This one will actually increase the difficulty about the vision of the drivers, and also may be tacky to the touch. Usually, bleeding is caused by high asphalt content or the low air void content. It will also result in low skid resistance. These two figures shows the examples about bleeding on the flexible pavement, and you will observe the asphalt mix on top of the surface. Slippage is another common distress of flexible pavement. Usually it's categorized by crescent or half-moon shaped cracks, and this type of cracks have two ends pointing to the direction of the traffic. Slippage is usually caused by a lack of the bond between the surface course and the underlying asphalt layer, and also the excessive deflection of the pavement structure. The deformation is highly related to the acceleration and deceleration behaviors of vehicles on the road. Usually, when the vehicle is making acceleration or deceleration, the shear force applied to the pavement reaches to the highest value, and if the surface mix does not have high strength, it will be easy to create a slippage on the road. It will also happens at the location where vehicle makes turns or the vehicle frequently stops. Shelving is another type of distress which is very similar to slippage. It represents a longitudinal displacement of local areas of the pavement surface. Usually it's caused by the braking or accelerating behaviors of vehicles on the road. And you will observe this one a lot on hills or curves or at intersection. The figure at the bottom demonstrates one example about shelving at intersection. Shelving distress also may have some vertical displacement about the pavement materials. The distress related to raveling and weathering is usually categorized by wearing away of pavement surface in high-quality hot mixed asphalt concrete. In general, it's caused by the disloading of aggregate particles and the loss of asphalt. Usually, raveling starts from loss of fines to loss of some coarse aggregate, and eventually to a very rough and pitted surface with obvious loss of aggregate. With raveling, the road surface is not smooth, and it cannot provide a smooth ride for vehicles on the road. There are some possible causes about raveling, including excessive hardening of asphalt binder, poor quality mixture, and also it's highly related to the presence of both traffic and weather on the pavement. Here are some examples about raveling and weathering. When you go to check the details about the road surface, you will observe some erosions on the surface, which will make the pavement less smooth, and it will reduce the experience of the vehicles on the road. Patching and potholes are also very common on the road. They represent the ball-shaped holes of various sizes in the pavement surface. Usually it's caused by broken pavement surface due to the fatigue cracking, localized disintegration, or freeze-thaw cycles. Flexible pavement will also experience striping, or we call it moisture damage. It's categorized by the loss of the adhesive bond between the asphalt, cement, and aggregate. Usually, this type of distress is caused by the presence of the water in asphalt concrete. The figures below demonstrate the asphalt concrete with moisture damages. Striping is also related to many other types of the distress in flexible pavement, such as rutting, fatigue cracking, raveling, and loss of stability. The last stress of flexible pavement that we will learn is patching. Patching is an area of pavement surface that has been removed and replaced with patching material, or an area of pavement surface that has had additional patching material applied. Patching may occur on partial lane or full lane width, or even the whole road. Usually there will be some cracks occurs at the joint of patching and the original pavement. Also, it's able to increase the roughness of the pavement surface. And now for rigid pavement distress, usually the rigid pavement distress can be categorized into 4 types: cracking, joint deficiencies, surface defects, and miscellaneous distresses. Cracking in rigid pavement can be divided into 4 types: corner breaks, durability cracking, longitudinal cracking, and transverse cracking. First, the corner breaks will usually create cracks which will intersect adjacent transverse and longitudinal joints of concrete slabs, and they will form the angle about 45 degrees to the direction of the traffic. Usually the length of the site varies from 1 feet to half width of the slab. The figures on the right demonstrate some corner breaks on the second one, durability cracking, which is also called a decracking, will form some closely spaced crescent-shaped hairline cracking patterns along the concrete slab. The two figures below shows the example of moderate severity decracking. You will observe a clear D shape along the PCC slab, and the one on the right shows the high severity decracking, and there will be a lot of loose and missing materials at the joint and corner of the slab. The longitudinal cracking can also occur on rigid pavement. Similar to the flexible pavement, longitudinal cracks will be parallel to the pavement center line, and there will be two examples about the longitudinal cracking along the rigid pavement. Here will be the top-down view and the cross-section view about longitudinal cracking. It's also possible that you will observe some missing materials along the longitudinal cracking. It can happen at one side of the cracks or both sides of the cracks. Transverse cracking is also common for rigid pavement. This type of cracking will create cracks which are perpendicular to the pavement center line, and transverse cracking can extend the cracks to partial travel line or to all the travel lines along the road. Similarly, we will have the cross-section view and top-down view about transverse cracking, and you will see that the cracks were perpendicular to the center line and the lane markers. Also, it's possible that you will observe some materials missing. It can happen at both sides of the cracks or one side of it. Faulting is one unique distress for rigid pavement. This one will generate differences in elevation across a joint or crack on the road. The two figures here shows the cross-section view and top-down view of faulting for rigid pavement. From the cross-section view, you can clearly see that the elevation difference between the faulting region and the original pavement. And the faulting will actually increase the roughness of the road surface. Rigid pavement will also experience the pumping and water bleeding issues, and this issue is generally categorized by seeping or ejection of water from beneath the pavement through cracks. The issues can be easily detected by deposit of the fine materials left on the pavement surface. These two figures demonstrate the examples of pumping and water bleeding effect under rigid pavement. Another type of distress for rigid pavement is punch out, which is the separation of the block of concrete from the rest of the pavement. Usually it's formed by two closely spaced transverse cracks and short longitudinal cracks and the edge of the pavement or the longitudinal joint. It can happen at the edge of the pavement or in the middle of the pavement. Lane to shoulder drop-off is also one typical distress of rigid pavement. It will cause a difference in elevation between the edge of the slab and the outside shoulders. This one typically occurs when the outside shoulder settles. The figure here actually shows the top-down view and the cross-section view for the lane to shoulder separation. The joint between the edge and the slab will actually become larger, and they will cause a lot of issues, especially about issues to the lower layers about the pavement. That's all about the introduction of pavement distress. Please keep in mind that it's very important for us to understand the categories of the distress and their potential causes. It's very useful for us to choose appropriate materials and pavement structures to make sure that the pavement can sustain for a longer time. and we will use the information in this tutorial session a lot in the future lectures. So that will be all about the tutorial session today. Thank you very much for your attention, and I will see you next week.